In this lecture, we'll talk about the binomial theorem. Let's start by talking about the motivation behind the binomial theorem. Previously, we learned that the square of a binomial, x plus a squared, can be written as x squared plus 2ax plus a squared. Similarly, we learned that the cube of a binomial, x plus a cubed, can be written as x cubed plus 3ax squared plus 3a squared x plus a cubed. With that in mind, is there a generic way to write a binomial raised to the nth power? And that's what the binomial theorem does. The binomial theorem gives us a formula for computing the expansion of x plus a raised to the nth power. So before we can talk about the binomial theorem, we need to review a couple things. First is the concept of factorials. If you see a number n with an exclamation point behind it, that's called n factorial. And what that means is to take and multiply all of the numbers that starting at 1 up to n together. So if I see 3 factorial, that means 1 times 2 times 3, which would give me 6. And if I see 8 factorial, that would be 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8, which would give me 40,320. And just as a note, when we're working with factorials, if you encounter 0 factorial, that will be equal to 1. And the other topic that we need to discuss before we can talk about the binomial theorem is n choose j. So if you see a set of parentheses with an n and a j, with the n being above j, that's called n choose j. And we evaluate n choose j using this formula. N choose j is equal to n factorial divided by j factorial times n minus j factorial. So let's look at a couple of examples where we evaluate n choose j. Let's start with 7 choose 5. If we plug 7 in for n and 5 in for j for the formula on the previous slide, we would get 7 factorial divided by 5 factorial times 7 minus 5 factorial. This gives us 7 factorial divided by 5 factorial times 2 factorial. And if we expand the factorials, we'll get 1 times 2 times 3 times 4 times 5 times 6 times 7 divided by 1 times 2 times 3 times 4 times 5 times 1 times 2. And we have common factors in both the numerator and denominator, so we can cancel out the 1 through 5 in both top and bottom, leaving us with 6 times 7 divided by 1 times 2. If we simplify that, we'll get 42 divided by 2, which we can evaluate as 21. Let's try 9 choose 7. So again, plugging 9 in for n and 7 in for j, we would get 9 factorial divided by 7 factorial times 9 minus 7 factorial. That gives us 9 factorial divided by 7 factorial times 2 factorial. If we expand our factorials, we'll get 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 divided by 1 times 2 times 3 times 4 times 5 times 6 times 7 times 1 times 2. So the product of the numbers 1 through 7 cancel out in both the numerator and denominator, leaving us with 8 times 9 divided by 1 times 2, which is 72 divided by 2. And if we simplify that, that gives us 36. Let's look at one last example. This time we want to determine what 5 choose 2 is. Take a couple minutes and try to figure it out. If you get stuck or finish, feel free to continue the lecture to work along with me. Since we're trying to evaluate 5 choose 2, we're going to plug 5 into the formula for n and 2 into the formula for j, which gives us 5 factorial divided by 2 factorial times 5 minus 2 factorial. If we simplify, that'll be 5 factorial divided by 2 factorial times 3 factorial. If we write out the factorials, we'll have 1 times 2 times 3 times 4 times 5 divided by 1 times 2 times 1 times 2 times 3. The product of 1 through 3 cancels out in both the top and the bottom, leaving us with 4 times 5 divided by 1 times 2. If we simplify that, that'll give us 20 divided by 2. And so 5 choose 2 is equal to 10. So now that we've talked about n choose j, we can talk about the binomial theorem. The binomial theorem says x plus a raised to the nth power will be n choose 0 times x to the n plus n choose 1 times a times x to the n minus 1 plus n choose 2 times a squared times x to the n minus 2. And so for each additional term, the j part of n choose j will increase by 1, the power of a will increase by 1, and the power of x will decrease by 1. So let's look at an example. We want to use the binomial theorem to evaluate x minus 1 to the 5th power. So to use the binomial theorem, we're going to note that a is equal to negative 1 and n is equal to 5. So if we plug these into the binomial theorem, we'll get 5 choose 0 times x to the 5th plus 5 choose 1 times negative 1 times x to the 4th plus 5 choose 2 times negative 1 squared times x cubed plus 5 choose 3 times negative 1 cubed times x squared plus 5 choose 4 times negative 1 to the 4th times x plus 5 choose 5 times negative 1 to the 5th. So again, notice with each term, the j part of n choose j increases by 1, the power on your a value increases by 1, and the power on your x term decreases by 1. In order to simplify this binomial theorem, we're going to evaluate our coefficients, the n choose j's. So we'll start with 5 choose 0. If we plug 5 in for n and 0 in for j, we'll get 5 factorial divided by 0 factorial times 5 factorial, which if we expand gives us 1 times 2 times 3 times 4 times 5 divided by 1 times 1 times 2 times 3 times 4 times 5. The product of 1 through 5 cancel out in the numerator and denominator, leaving us with 1 over 1, and so 5 choose 0 is equal to 1. Next we'll look at 5 choose 1. This time we plug 5 in for n and 1 in for j, so we'll get 5 factorial over 1 factorial times 4 factorial. If we expand, we get 1 times 2 times 3 times 4 times 5, divided by 1 times 2 times 3 times 4. The product of 1 through 4 cancel out in both the top and the bottom, leaving us with 5 divided by 1, so 5 choose 1 is equal to 5. We continue with 5 choose 2, where 5 is equal to n and 2 is j. That'll give us 5 factorial over 2 factorial times 3 factorial, which if we expand gives us 1 times 2 times 3 times 4 times 5, divided by 1 times 2, times 1 times 2 times 3. The product of 1 through 3 cancels out in the numerator and denominator, leaving us with 4 times 5, divided by 1 times 2, which is 20 over 2, so 5 choose 2 is equal to 10. If we look at 5 choose 3, that'll be 5 factorial over 3 factorial times 2 factorial. Well, this is essentially the same thing we had for 5 choose 2, so we'll again get the value of 10. 5 choose 4 gives us 5 factorial over 4 factorial times 1 factorial. That's the same as we had for 5 choose 1, so that'll give us a value of 5. And 5 choose 5 would be 5 factorial over 5 factorial times 0 factorial, which is the same thing as 5 choose 0, which gives us 1. So if we look back at our binomial expansion, we have 5 choose 0 times x to the 5th, plus 5 choose 1 times negative 1 times x to the 4th, plus 5 choose 2 times negative 1 squared times x cubed, plus 5 choose 3 times negative 1 cubed times x squared, plus 5 choose 4 times negative 1 to the 4th times x, plus 5 choose 5 times negative 1 to the 5th. So if we go through and we evaluate the negative 1 raised to the powers, and we evaluate our n choose j's, we plug in those coefficients, we'll get the following. 1 times x to the 5th, plus 5 times negative 1 times x to the 4th, plus 10 times 1 times x cubed, plus 10 times negative 1 times x squared, plus 5 times 1 times x, plus 1 times negative 1. So again, we just evaluated the negative 1 to the powers, and we inserted the coefficients for our n choose j's. And so if we simplify, we get x minus 1 to the 5th is equal to x to the 5th minus 5x to the 4th plus 10x cubed minus 10x squared plus 5x minus 1. Let's look at another example. This time we want to expand 2x plus 3 raised to the 5th power. So for this, our a value is equal to 3, our n is equal to 5, and this is going to be a little bit different because the first term is 2x instead of x. So if we use the formula for the binomial expansion, we'll get 5 choose 0 times 2x to the 5th, plus 5 choose 1 times 3 times 2x to the 4th, plus 5 choose 2 times 3 squared times 2x cubed, plus 5 choose 3 times 3 cubed times 2x squared, plus 5 choose 4 times 3 to the 4th times 2x, plus 5 choose 5 times 3 to the 5th. Now, since our coefficients, the n choose j's, are the same as the previous example, we'll just go ahead and put in those values that we've already found. 5 choose 0 is equal to 1, 5 choose 1 is equal to 5, 5 choose 2 is equal to 10, 5 choose 3 is equal to 10, 5 choose 4 is equal to 5, and 5 choose 5 is equal to 1. The next thing we're going to do is we're going to evaluate our exponents. So if we evaluate the 2x raised to each power and the 3 raised to the individual powers, our expansion becomes 1 times 32x to the 5th, plus 5 times 3 times 16x to the 4th, plus 10 times 9 times 8x cubed, plus 10 times 27 times 4x squared, plus 5 times 81 times 2x, plus 1 times 243. If we simplify the multiplication, we're going to get 32x to the 5th, plus 240x to the 4th, plus 720x cubed, plus 1080x squared, plus 405x, plus 243. And so the last thing that we're going to talk about with the binomial theorem is finding a particular coefficient for a binomial expansion. So based on the binomial theorem, the x to the j term of x plus a to the nth power is n, choose n minus j, times a to the n minus j times x to the j power. So let's look at an example. We want to find the coefficient of the x cubed term in the expansion of x minus 3 to the 10th power. So for this expansion, n is equal to 10. We're looking for the cubed term, so j is equal to 3, and the a value from our expansion is negative 3. We'll use the formula from the previous slide, n choose n minus j, times a to the n minus j, times x to the j power, and that'll give us 10 choose 7, times negative 3 to the 7th power, times x cubed. So let's start by identifying our 10 choose 7. 10 is equal to n, 7 is equal to j. If we plug that into our n choose j formula, we get 10 factorial divided by 7 factorial times 3 factorial. If we expand, we get 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 in our numerator, and 1 times 2 times 3 times 4 times 5 times 6 times 7 times 1 times 2 times 3 in the denominator. The product of 1 through 7 cancel out in both the top and the bottom, leaving us with 8 times 9 times 10 over 1 times 2 times 3, which would be 720 over 6, and 720 over 6 simplifies to be 120. So we can plug that in for 10 choose 7. That means that the x cubed term will be 120 times negative 3 to the 7th power times x cubed. Negative 3 to the 7th power is negative 2,187, so we have 120 times negative 2187 times x cubed. If we simplify the multiplication, we get negative 262,440 times x cubed, and so the coefficient is negative 262,440. For our final example, we want to find the x cubed term in the expansion 2x plus 1 to the 12th. So this time, our n is equal to 12, our j is equal to 3, our a is equal to 1, and our first term is going to be 2x instead of just x. Again, we'll use the formula n choose n minus j times a to the n minus j times x to the j power, which will give us 12 choose 9 times 1 to the 9th times 2x quantity cubed. First thing we want to do is identify what 12 choose 9 is. So we have 12 factorial over 9 factorial times 3 factorial. That'll give us the product of the numbers from 1 to 12. divided by the product of the numbers of 1 through 9 times 1 times 2 times 3. The product of the numbers 1 through 9 cancel out from both the numerator and denominator, leaving us 10 times 11 times 12 over 1 times 2 times 3. If we simplify that multiplication, we'll get 1,320 divided by 6, which is going to be 220. So our formula becomes 220 times 1 to the 9th power times 2x quantity cubed. If we evaluate our exponents, 1 to the 9th is still 1, and 2x quantity cubed gives us 8x cubed, so we're left with 220 times 1 times 8x cubed. If we multiply that out, that's going to give us 1,760 x cubed, and so the coefficient of the x cubed term is going to be 1,760.